Good morning, students. Today's lesson, Unit 8, Periodic Classification of Elements. Unit 8, Periodic Classification of Elements. The periodic classification of elements, learning objectives, atomic radius, ionic radii, ionization energy, electron affinity, and periodic properties. Atomic radius, ionic radii, ionization energy, electron affinity, and periodic properties. The electronic configuration of elements help us to explain the physical and chemical properties. The chemical properties also explained by the electronic configuration. So, the electronic configuration is very important. Anything which repeats itself after a regular interval is called a periodic. That is, the properties also repeats itself after a regular interval is called periodic, and this behavior, this property is called periodicity. What is periodicity? Anything in the periodic table, the properties of the elements which repeats itself after a regular interval is called periodic, and this behavior is called periodicity. Some of the atomic properties of the elements are the periodic. The atomic properties. So, this is a electronic configuration. So, it has different cells S, P, D, F, 4 orbits, S orbit, P orbit, D orbit, and F orbit. The properties such as atomic radius, ionic radius, ionization energy, electronegativity, electron affinity show a regular periodicity, and hence they are called periodic properties. The properties such as atomic radius, ionic radius, ionization energy, electronegativity, electron affinity also totally called periodic properties of the elements. First, atomic radius. What is atomic radius? Atomic radius of an element or atom is defined as the distance between the center of its nucleus. This is the nucleus of the atom. This is the center of the nucleus and the outermost shell containing the valence electron. Valence electron present in the outermost shell. So, atomic radius of an element or the particular atom is defined as the distance between the center of the nucleus and the outermost shell containing the valence electron. Except for noble gases, the atomic radius is referred to as covalent or metallic radius, depending on the nature of the bonding between the atoms. Between the atoms, there is formed the bonds. So, except for noble gases, the atomic radius is referred to as covalent or metallic radius based on the nature of the bond between the atoms. So, types, atomic radius is in the metal atoms is known as metallic radius. First type, metallic radius. Atomic radius in metal atoms is known as metallic radius. It is defined as half the distance between the nuclei of adjacent metal atoms. It is defined as half the distance. So, from the center of the nucleus to the outermost shell of the atom. Here, the center of the nucleus to the outermost shell of the atom. It is defined as half the distance between the adjacent nuclei of the metal atoms. This is metallic radius. So, metallic radius in the atoms So here from right to left increase the atomic radius. The metallic atoms, the atomic radius is from right to left, that is increase. Helium, hydrogen. Here neon, fluorine, oxygen, then lithium. From right to left, that is the atomic radius is increase. At the same time, in top to bottom in a group, atomic radius is increase. Hydrogen atomic radius, that is 37, then lithium 152, sodium 186, then potassium 227, rubidium 248, and cesium 265. The atomic radius increased from right to left. At the same time, atomic radius increases from top to bottom in a group. In non-metallic elements, their atomic radius is known as covalent radius. In non-metallic elements, their atomic radius is known as covalent radius. It is defined as half the distance between the adjacent nuclei of the covalent bonded atoms of the same element in a molecule. Same element in a molecule. In non-metallic elements, so this is non-metallic elements, their atomic radius is known as covalent radius. It is defined as half the distance between the adjacent nuclei. Half the distance between the adjacent nuclei. First atom, second atom. So this is a nucleus to the outermost shell, nucleus to the outermost shell. It is defined as half the distance between the adjacent nuclei of two covalently bonded atoms of the same element in a molecule. So this is a covalent radius. In hydrogen atoms, the atomic radius of hydrogen. For example, let us consider hydrogen molecule. This is a hydrogen molecule. The distance between the two hydrogen nuclei, first hydrogen atom, second hydrogen atom, the distance between the two hydrogen nuclei of the molecule is 0.74 angstrom, and also it is also called picometers. Let us consider the hydrogen molecule. The distance between the two hydrogen nuclei of the molecule is 0.74 angstrom or picometers. This is denoted as a letter PM or angstroms A. So its covalent radius is 0.74 by 2 is equal to 0.37 angstrom. This is the atomic radius of hydrogen molecule. Then along the period from left to right, along the period from left to right, in the period, this is called a period. The top to bottom is called group. Along the period from left to right, the atomic radius of the elements decreases, whereas along the groups, here this is a period, this is a group, the atomic radius of the elements decreases from left to right, whereas along the groups, that is in the group top to bottom, from the top to bottom the atomic radius increases. So the atomic radius is increases. The first period, second period, this is the third period of the element. The increase of the atomic radius is due to the increase in the valence shell. So in the first period and compared to the second period, so number of shells are also increased. The increase of the atomic radius is due to the increase in the valence shell number down the group. As the cell number increases, a cell number, here 2 cells, 3 cells, here 4 cells. As the cell number increases, the distance between the valence shell and the nucleus is also increases. This is a nucleus, this is a valence shell. Nucleus to valence shell. nucleus to valence shell. This is also increased. Here only 2 cells, here 3 cells, here 4 cells. So the distance between the valence shell and the nucleus increases. Along the period, the cell number remains the same. This is the period. The cell number is also same. In the first period, there are 2 cells. This is also first period element, 2 cells. In period 2, so this is the first hydrogen, first period. In the second period, there is 1, 2, 3. So here only first shell as occupies 2 electrons. It's possible to occupy 2 electrons. Hydrogen atomic number 1, so only 1 electron in the outmost shell. Helium atomic number 2, 2 electron in the outmost shell. So the first period element has only 1 cell. This is the outmost cell. So this is a period second period elements. So lithium, there's 2 cells. Here also 2 cells in the period. So it has the same number of cells. Along the period, the shell number remains the same, but the number of protons, that is atomic number, increases from left to right. For hydrogen atomic number 1, helium atomic number 2. So atomic number is increases. More and more positive charges impose a strong attraction over the electrons. So from left to right, the atomic number is increased. So number of protons is also increased. So more and more positive charges impose a strong attraction over the electrons, and thus electron cloud shrink towards the nucleus. So number of protons is increased, the positive charge is also increased. So it is also easily attract the outermost shell. So the electrons and the electron cloud shrinks towards the nucleus, which results in the decrease in the atomic size. So atomic size is also decreased. Atomic radius decreases from lithium to boron. Lithium atomic number 3, boron atomic number 5. So atomic number decreases. Atomic number from left to right increases. Atomic radius decreases from lithium to boron. Then ionic radii. What is ionic radii? It is defined as the distance from the center of the nucleus of the ion up to the electron cloud of the ion. Electron cloud out, that is outermost shell. Ions are formed when an atom loses or gains electrons. Then ions are formed when an atom loses or gains electrons. When a neutral atom loses an electron, it becomes a positively charged ion called cation. The positively charged ion is called cation. Positively charged ion is called cation. This is anion, negatively charged ion. Whereas the gain of an electron by a neutral atom forms a negatively charged ion called anion. So the size of the cation always is smaller. Size of the cation size is smaller. Anion size is greater than the other one. So the size of the cation always smaller. Size of the anion is larger. So anion is larger, cation is smaller. Here cation smaller, anion larger. The size of the cation always smaller, size of the anion is always larger. Atomic radius versus ionic radius. The radius of a positive ion is smaller than atomic radius of the element. So the ionic radius of a positive ion, this is a positive ion, is smaller than the atomic radius of the element. This is a smaller in size, this is a greater in size. The ionic radius of a negative ion is larger than atomic radius of the element. Then ionization energy. Ionization energy is the minimum energy required to remove an electron from an isolated gaseous atom to form a cation. Ionization energy is the minimum energy required to remove an electron from an isolated gaseous atom to form a cation. It is otherwise called ionization enthalpy. What is ionization energy or what is ionization enthalpy? Both also same. It is measured in kilojoule per mole. Higher the ionization energy, so the ionization energy is increased, it is more difficult to remove the electron from the outermost shell. As the atomic size decreases from left to right in a period, more energy is required to remove the electrons. As the atomic size decreases from left to right in a period, more energy is required to remove the electrons. So the ionization energy is increases along the period. At the same time, down the group, that is in the group, the atomic size increases and hence the valence electrons are loosely bound. Down the group, this is a group, first group elements. The atomic size increases. Here atomic size also increases in the group. The valence electrons are loosely bound. The valence electrons are also loosely bound. They require relatively less energy for the removal. Thus, ionization energy decreases down the group in the periodic table. Then electron affinity. Electron affinity is the amount of energy released when an isolated gaseous atom gains an electron to form its anion. So, electron affinity. This is atom, this is ion. Electron affinity is the amount of energy released when an isolated gaseous atom gains an electron to form its anion. It is also measured in kilojoule per mole. Electron affinity also increases from left to right in a period. When we move in the period from left to right, electron affinity also increases and decreases from the top to bottom in a group. At the same time, in a group from top to bottom, this decreases. So, overall, the periodic properties. In a period in a group, the atomic radius decreases in period, the atomic radius increases in groups. The ionic radius decreases in periods, increases in groups. Ionization energy increases in periods, decreases in groups. Electron affinity increases in periods, decreases in groups. The electronegativity also increases in periods, decreases in groups. So, periodic trends from left to right in the periodic table, the ionization energy is increased. Electron affinity also increased. In top to bottom, the atomic radius is increased. From right to left, the atomic radius is increased. At the same time, the metallic character is also increased from right to left. A non-metallic character is increased from left to right. This is overall a periodic trends of the elements. Thank you, students.